Okay, so it says the velocity function is given, find the displacement and the distance traveled. And you were having trouble with distance traveled, right? So let's just do part B there. So distance traveled, what do you have to do when you do the integral here? Yeah, you have to do the absolute value of it, right? So we got 3t minus 5. So I would write this out because if it's free response by chance, you'll get points for showing your step 1. And we're going from 0 to 3. So we're trying to find where the 3t minus 5 is equal to 0, which would be 5/3. So then we're going to split it. So we're going from 0 to 5/3, and then from 5/3 to 3. And if I go 0 to 5/3, I'm just going to pick 1, positive or negative? Negative. So do you have to change the sign? Yes. So it'll be the opposite of 3t minus 5. And then from 5/3 to 3, we can pick 2, and it's positive, right? And just somehow you weren't getting the right answer, it sounds like, right? Okay, so let's just do this part here first. So this is negative 3t plus 5, just so I don't mess that up. So antiderivative, we do t squared over 2, so is this what you got? And then plus 5t, going from 0 to 5/3. Okay, and 5/3 squared would give us 25/9. And then subtract, and we plug in 0, which is just going to give us zeros, right? Okay, so this part here, if we reduce it down, the 3 and the 9 will make this a 3. We get negative 25/6. Plus, this would be 25/3, which would be 50/6. So I end up with 25/6 for an answer for that chunk. Does that seem right? Okay. And then I'm going to do the other chunk. It's just a little easier, less overwhelming, I feel like. So same idea with that one. We get the t squared over 2, which gives us a 3/2 out front, minus 5t. So I'll plug in 3 first. And then we're going to subtract and plug in the 5/3. Okay, so up front we got 27/2. Let me know if I do something wrong. Minus 15 and then minus. I'm going to keep the parentheses for the moment. Here, same idea as what we just did. We get 25/6. This is just in the parentheses, so there's still the minus out front. And then minus 25/3, which would be 50/6. So in the parentheses, I have a negative 25/6. So that'll make that a plus. And then I suppose, because we're probably trying to do this without our calculator, we get a common denominator type of a thing. So this here, we'd have to multiply by 3. So 27 times 3. Show your work off to the side. Show you didn't use your calculator. Okay, 20 times 3 gives me 60. 7 times 3 gives me 21, so I get 81. I think that's quicker. I like it. It's kind of like the new math. Then this one, we're trying to get over 6, so we're doing 15 times 6. So I do 6 times 10, which gives me 60, and 6 times 5, which gives me 30, and I add those together. I mean, I do it in my head, but that way you can see what I'm doing. it's like retraining your brain to do it a different way. You don't have to do it like that, but it makes it quicker. And I'm doing this for like the long run, you know, mental math for the rest of my life. I figured I'd try to train my brain. And then plus 25/6. So we're doing 81 and 25 are the positive pieces. And then subtracting 90. So what do I get there? 16/6. And I'm going to leave it like that because these have a common denominator then, right? Versus like reducing that down. And then I'm adding those two pieces together. So if I add those two pieces together, 25 and 16 gives me 41. So 41/6. Does that reduce at all? No, and I don't need to reduce it anyway, but double check it. Does that match what it's supposed to? Hopefully. Okay. Okay, and then 57, the acceleration function and the initial velocity are given. Find the velocity at time t. So first we're just trying to do the antiderivative here, velocity at t. So that's antiderivative would be t squared over 2, so half t squared plus 4t and then plus c, right? And then how do I solve for my c? Plug this in, right? And we can do that with mental math here really quick. If we plug 0 in for t, those go away. So we just have c on this side and 5 on that side. So c equals 5. So then our velocity at time t is just that, right? That look right to you guys? Okay, and then the distance traveled during the given time interval. So when we're doing distance traveled, it's the same thing as like what we did on the last page there. Distance traveled, you do the integral, and we put the absolute value of the velocity. And we're going from 0 to 10. Did we just have trouble setting that to 0, maybe? Yeah. Okay. Oh, it doesn't? Okay. Yeah. Because if you're trying to solve this, if we set that equal to 0, I'd probably times everything by 2. Then you would have like t squared plus 8t plus 10 equals 0. And then you could try to factor. Sometimes it still won't factor, but then you try to add to here, multiply to here. Typically, if it's a no calculator AP question, it's like easily factored into 2 chunks. Is this one factorable? Where we get like the t and they add to here and multiply to here. Multiplying to 10 would be 10 and 1 or 5 and 2. That's not going to work, right? So this would end up being a calculator question. Obviously, we could jump to like negative b plus or minus square root. They're not going to make you do that on the AP test. So then at this point, if it's not factorable, use your calculator, and then all you have to do in your calculator is throw this into your y1 or this, either way, and find when it's equal to 0, and you said it's never? 0 to 10, it's always positive? Okay, well that makes sense, yeah. Yeah, look at you using like logic, yeah. If you look at plugging anything between 0 to 10 in here, it's always positive, yeah. So then we're just doing from 0 to 10, and do we have to change the sign? And you have to still be careful of that, because if it's negative, then you have to change the sign. You know, you might think, oh, I don't have to break it and then just leave it, but here we don't have to change it at all, so we'll just leave it like this. Do you need help finishing it, or was it okay from there? Okay from there, probably? I'll let you finish it up then.